Hello everyone, welcome back. Let us continue our discussion. We are in week 11 and this is our third lecture. So, we have studied Castigliano theorem, and if you recall, we have first defined the strain energy stored within an elastic body, and if we differentiate that strain energy with respect to the generalized displacement along rth degrees of freedom, so we'll get actually the force here. So this is the first theorem of Castigliano that we have derived earlier. Now the second theorem tells that if we differentiate the strain energy with respect to the rth force, we get the displacement along that force, right? And this is the second theorem. And we have also solved some example using this theorem, and you have seen how we can quantify the actual strain energy, bending strain energy, shear strain energy, and torsional strain energy, right? And for every elastic deformation, we can quantify the strain energy, and the moment we quantify the strain energy, we can find out the displacement along the force, rth force, and that gives us the clue how to evaluate the displacement. Okay. So at any given point, for example, if we consider a beam, and at any location of the beam, if we want to find out the displacement, we actually put a dummy load there and then find out the total strain energy and then differentiate that with respect to the dummy load, and ultimately we put that dummy load equal to 0, then we get the displacement. In fact, we can also find out the rotation at any particular point, and for that we have to actually apply a dummy moment instead of a force, right? That we have discussed in detail. So let us take some example today. So we have our first example is, as you can see, we have this circular arch and it has one end, say A, on hinge, and another end, say B, it is on roller. And at this support, what we do, we apply a horizontal force P. Now our task is to find the displacement at B in the horizontal direction. Okay, so for that what we do, we consider a small segment of the arch, say this is D of S. Now we can find out the moment at this point, which is caused by the force P acting at B along the horizontal direction. The radius of this arch is capital R, and let this angle be theta. So this small angle here is d theta. Obviously, ds is equal to r times d theta. Now, at this point, say C, what is the lever arm from this force P? This is r sine theta. So we can calculate m, say x, or we can call it theta, is equal to P times the distance, so that is r sine theta. So the strain energy due to bending at this location, we can find out. So that is m theta square then times ds divided by twice ei, and that we integrate between 0 to pi by 2 and multiply that. Because of the symmetry, we can find out the total bending strain energy. Okay. So we have 2 times 0 to pi by 2. In place of m theta, we can write p r sine theta whole square. Then we can replace ds with r d theta divided by twice ei. So then if you simplify, we have p square r cube divided by ei, then integral 0 to pi by 2, we have sine square theta d theta. Now if we complete this integration, we get the total bending strain energy is p square r cube divided by ei times pi by 4. Therefore, if we differentiate this bending strain energy with respect to the force P, we get delta B horizontal, and which is equal to pi P r cube divided by twice ei. So now you can see we can solve the displacement at the roller support due to the application of this force P using theorem of Castigliano. Right? This is the second theorem of Castigliano that we have applied. Let us take a different example. So our example 2 is a bracket and the dimension is given. So the length for AB is L, and for the entire bracket we have EI, and BC has a height H. Now here we apply a force P at C. Our task is to find out delta C. So we can split this into 2 segments. The first segment is BC and second segment is AB. So consider BC, and for this part let us consider a section at a distance, say x. So at this section we can evaluate what is mx, and that is equal to p times x. Therefore, the bending strain energy in segment 1 is 0 to height h, mx, which is p times x whole square, dx divided by twice ei. So the bending strain energy in this part we have p square h cube divided by 6ei. Now let us consider the remaining part, that is AB. For this part, let us consider a section at a distance x. Now, for this part, we need to calculate the reactions. So, we have RA and RB. Now, if we take the moment about the point A, so we have RB times L is equal to P times H. So, RB is equal to PH divided by L. Therefore, we can calculate Mx, which is P times H minus RB, which is PH by L times X. So effectively we have P times H by L, and within bracket we have L minus H, L minus X. So bending strain energy for the second part is 0 to L, then PH by L times L minus X whole square dx divided by Ci. So we have P square H square divided by EI twice EI L square, then integration 0 to L minus X whole square dx. So if we simplify this, we have P square H square divided by 6 EI L square. Then we have L minus X whole cube. Then there will be a minus here, and that is evaluated between 0 to L. So UB 2 is equal to, we have P square H square divided by 6 EI L square, and then we have minus L minus X whole cube 0 to L. So we have P square H square divided by 6 EI L square and then L cube. So we can simplify this. We have L here. So effectively P square H square L divided by 6A. Now total bending strain energy is P square H cube divided by 6EI plus P square H square L divided by 6E. That is P square H square divided by 6 EI times H plus L. So now if we differentiate this total strain energy with respect to P, the applied force, we have P times H square divided by 3 EI, then within bracket H plus L, and that is the displacement C, right? So this is displacement C. So we get the displacement at the point C due to this horizontal force P at this point. So you can see how we can use the theorem of Castigliano to solve the problem to find out the displacement, and also we can find out rotation. For example, if this problem, if we find out the rotation at this point C, then we have to first apply a dummy force M, and then using this M we have to find out the bending strain energy, and that we have to differentiate with respect to M, which will give us the rotation at that particular point. So follow these examples and the theory, and also we'll provide some problem. Just solve those problems. That will give you confidence. If you have any trouble, do let us know through email or in our open session, then we will clear your doubt. Thank you very much.